Hi guys, so we're gonna be telling you explaining the answers to the first page on the pink sheet. So first we determined all the rational roots. So you take the factors of the very last integer, the one without an x on it, the constant, which is 3. And so you take all those factors, and the factors are 3 and 1. Then you take the number attached to the highest x value, which is the leading coefficient, which is 2x to the 3. So those factors are 2 and 1. And then you just determine all the possible rational roots. So 3 over 2, plus or minus 3 over 2, plus or minus 1 over 2, plus or minus 3 over 1, which is just 3, and plus or minus 1 over 1, which is also just 1. All right, now that we have those, we can start factoring out. So we decided to use 1 because it's just the easiest, simplest one. So using synthetic division, we checked if 1 worked as a root. So drop the 2 down. Then 1 times 2 is 2. Negative 7 plus 2 is negative 5. 1 times negative 5 is negative 5. 8 minus 5 is 3. 1 times 3 is 3. And it works because there's no remainder. So then we can figure out that x minus 1 times 2x squared minus 5x plus 3. And the 2x squared minus 5x plus 3 is what we got here when we use synthetic division to solve. So next, we knew that x minus 1 times 2x squared minus 5x plus 3 was equal to 2x to the 3 minus 7x squared plus 8x minus 3. So now we just had to figure out what factors went into 2x squared minus 5x plus 3. So we decided to try 1 again, just because it's easy. And remember, just because there's 1 works for the first one, it doesn't mean that it won't work for the second one. So 1 can work several times. So we tried it again. So 2, negative 5, 3. Drop the 2 down. So 1 times 2 is 2. Negative 5 plus 2 is negative 3. 1 times negative 3 is negative 3. And 3 minus 3 is 0. So it worked again. So now we know the factors are x minus 1. That's the first one that we figured out. X minus 1 again, because we just figured it out using this synthetic division. And 2x minus 3, because that's the remaining here using the synthetic division. All right, so now we have to state the end behavior, or the factors. So these are the factors, but we have to state the roots. So you set each of these equal to 0. So x minus 1 equals 0. One second. Okay, just keep going. Okay. So if you set x minus 1 to 0, x will equal 1. And x minus 1 set to 0 is also 1. So x minus 1 and 1, which is a double root. And then if we set 2x minus 3 to 0, you get 3 over 2. So the other root is 3 over 2. Now we have to state the end behavior. So in order to state the end behavior, we look at the leading coefficient. To state the end behavior, we look at the leading coefficient, which is 2x to the 3. So if as x goes towards positive infinity, imagine a positive number. So x to the 3, if you insert a positive number into the x, you'll still get a positive number. Times 2 is still a bigger positive number. So, as x goes towards positive infinity, y also goes towards positive infinity, or f of x goes towards positive infinity. Then, as x goes towards negative infinity, if you think about it and you insert a negative number into x to the 3, you're going to get out a negative number. Times 2 is still a negative number, so as x goes towards negative infinity, y goes towards negative infinity as well. In order to figure out now the y-intercept. In order to figure out the y-intercept, you put all of the factors, write out the factors, x minus 1, and 2x plus minus 3. So these are the factors. And in order to find the y-intercept, you have to set each of these, all of the x's equal to 0, because a y-intercept is where the x equals 0. So 0 minus 1, 0 minus 1, and 2 times 0 minus 3, sorry. So that's negative 1 times negative 1 times negative 3. And the negative ones cancel out to 1, so you end up getting negative 3. So the y-intercept is 0, 3. Or 0, 3. Negative 3. And you have to write it in these coordinate points. Now, in order to sketch the graph, all of this data, so we make an axis, a plane, a Cartesian coordinate plane. This is our Cartesian plane. Okay, now we can just start plotting. So we know the y-intercept is 0, negative 3, so there's a point right there, which is the y-intercept. Then there's a double root at 1, which is one of the x-intercepts, and there's also an x-intercept at 1.5, which is 3 over 2. 3 over 2 is 1.5. So then we can start graphing. So we know that it has to touch 0, 3, and we know that it has to touch 1 on the x-axis twice, and it has to touch 1.5 on the x-axis. So this is the line we came up with. And then down. Okay, yeah, more like that. Like that. And so it satisfies all of the requirements because it touches it touches 1 twice, and it also satisfies the end behavior. Thank you for watching our video.